This is the next how-to video in the series related to acid bases and buffers worksheet 1, in this case question 1 section K, and on the screen I've put down what that question relates to, and as a reminder I've once again put down some of the calculations we did for solution H and solution I. Now this question is not about adding just this solution to this solution. It's actually about adding equal volumes of solution H and solution I. So these numbers are largely irrelevant to any calculations we do. What we're really interested in here is the actual concentrations of the sodium hydroxide and the concentrations of the hydrochloric acid. And just sort of saying what this means, solution H has 0.5 moles of sodium hydroxide in every decimeter cubed, and solution I has 0.4 moles of hydrochloric acid in every decimeter cubed. So if we add a decimeter cubed of hydrochloric acid to a decimeter cubed of sodium hydroxide, what's going to happen is neutralization, and the acid molecules are going to neutralize the alkali molecules. So let's just do that. So there we go. What's happened is I've put a decimeter cubed of the acid into a decimeter cubed of the alkali, and 0.4 moles of hydrochloric acid has neutralized 0.4 moles of sodium hydroxide. So I've got 0.1 moles of sodium hydroxide left. Effectively I've taken this number away from this number, but that's now in 2 decimeters cubed. And whenever we're talking about doing calculations on pH, we're talking about concentrations of hydrogen ions or hydroxide ions in moles per decimeter cubed. So what we now have to do is to take this number and divide it by 2 to get it back into moles per decimeter cubed, and that's what I've done here. So this is effectively half of this. 0.1 mole in 2 decimeter cubed is the same as 0.5 mole in 1 decimeter cubed, and that's effectively the concentration of our sodium hydroxide. All of the acid has been neutralized. So now pH is a simple calculation again, isn't it? All we need to do is to do the pOH calculation, minus log of this number, and that will render us a value which we will then take away from 14 to get the final pH of the solution. So let's do that. So there we go. In this case, if we mix equal volumes of solution H and solution I together, we get a solution with a pH of 12.7. Thanks.